Greetings IT&T committee, visitors and listeners. Today I would like to present our research which is dedicated to the predictive data analysis subsystem for patients with subjective and mild cognitive impairment. Cognitive functions are an important property of the human body and are responsible for memory, mental performance and speech. In old age, there is an increased risk of cognitive impairment that can develop into severe disorders, including dementia, the prevalence of which in the population over 70 years is about 13.9%. The urgency of detecting violations at the earliest possible stage is determined by the extreme need to take measures to slow down the progression of the disease until the pathological process begins to affect the daily activities of a person. There's a group of deliberate cognitive impairments, which are often distinguished into mild and subjective cognitive disorders, the identification of which the presented work is aimed at. As part of the research, the goal was to develop a subsystem for identifying and determining cognitive impairments at an early stage based on the results of processing data from medical examinations of patients. To achieve this goal, it was necessary to solve several tasks presented on the slide. This slide shows a functional diagram of the proposed method. 6 main components are identified, consisting of data collection and pre-processing, working with a database, regression data analysis, data visualization, and subsequent display of text and visual results of the subsystem's work. The interaction of the user with the subsystem is carried out through a certain sequence of actions. Subsystem provides for the creation of a new database with historical data or selection of an existing one, import and export of the trained regression model for the analysis of tabular data. The result of the subsystem's work is 2 possible types of visualization, with the display of historical data and the trend of the patient's condition, as well as a text report with the preliminary diagnosis. The initial data are presented in the form of a CSV file and represent information about the patient and his result of passing various tests to assess cognitive functions. There are categorical and quantitative characteristics. An important feature of the data provided is the lack of consistency in the tabular data, with some empty fields filled by medical specialists. Each visit is represented by a set of 85 possible characteristics. Among the surveys provided, there were elements with missing characteristics, which significantly reduced the size of the original sample when trying to process only data with a full set of filled fields. It is important to note the presence of an imbalance in patients group. There are only 26 observations of control group, 122 observations of subjective cognitive impairment group, and 377 observations of mild cognitive impairment. Due to the limited data set, it was decided to prioritize processing as many surveys as possible. Data pre-processing consists of several stages. Initially, data of the CSV format is received as the input, followed by the conversion into structured data. Quantitative characteristics are selected from structured data. Thereafter, among each class of patients, exceptional observations that have been judged to be abnormal. In the process of considering possible methods for analyzing the data with the subsequent possibility of determining which group of patients the results of the considered medical examinations belong to, an analysis of various methods applied to solving the problem was carried out, and an approach based on regression analysis was chosen due to the need to obtain a result in the form of a real number, and also the need to identify the most significant characteristics for a diagnosis. Testing of 16 regression models was carried out using the metrics of the mean absolute error, mean squared error, and R2 score. Among the tested models, the gradient boosting method showed the best performance for the listed metrics. It is worth highlighting that the gradient boosting is based on decision trees, the features of which were subsequently used to find significant characteristics. This method is a method with a sequential learning process, in which the model is gradually changed to minimize the error, which in the case of data with unbalanced classes allows the model to take into account the classes with a small representation in the original sample. The process of changing the gradient boosting model can be represented using the figure in the lower left part of the slide. Among the disadvantages of gradient boosting, it is worth noting the complexity of setting up the model parameters. Regression analysis was used to preliminarily determine the current state of the patient, which will allow the medical specialist to predict the further course of the disease. As mentioned in the previous slide, through the use of decision trees underlying gradient boosting, it is possible to assess the significance of characteristics by calculating the significance factor based on the impurity coefficient. The formula for calculating the significance of each node in the tree is presented at the top of the slide, where n is the significance of the node j. This approach allows us to single out significant characteristics among the tabular data, which allows not only to increase interpretability of the results by reducing the considered characteristics, but also allows us to include in the regression analysis a set of surveys that previously could not be included due to the lack of non-empty characteristics, which makes it possible to analyze more data on a smaller number of investigated characteristics. This slide provides an example of finding significant characteristics when loading surveys. The figure on the left shows the state of the subsystem with the existing database with historical data. The initial analysis consists of a review of 480 surveys with 27 characteristics. The arrow marks the process during which the file is loaded with the survey results that need to be analyzed. Before loading the file, the regression model was already trained on historical data. By reducing the considered characteristics, the number of examined surveys increased from 480 to 525. The most significant characteristics are highlighted in the table, where green is less significant, orange is of medium significance, red is of high significance. This iterative approach can be performed as long as insignificant characteristics remain. Visualization in the subsystem is represented by displaying two possible figures. The first of them is the demonstration of the results of the regression analysis on the coordinate plane, where the x-axis is the visit number and the y-axis is the result of the regression model. As noted earlier, the results of the regression analysis will allow the medical professional to predict the further course of the disease. The second figure is a visual representation of the results of patient examinations in a two-dimensional space. Different groups of patients are highlighted in different colors. In addition to auxiliary visual tools, a text report was presented with the interpretation of the regression model results. The suggested diagnosis is made following the given system in the upper left corner. This method of making a preliminary diagnosis is a decision support method. The graphical interface is presented as follows. Window 1 provides the choice of creating a new database with historical data or choosing an existing database. Window 2 is the main window and consists of 3 parts. On the right side, there's a table of considered observations. On the top left, there's a component for displaying a patient's impairment trend and displaying historical data in two-dimensional space. In the lower left part of the window, there's a text report with the preliminary diagnosis. As part of the research done, several studies were carried out, including finding statistically significant characteristics among patient groups, evaluating the methods used in the subsystem, adjusting the parameters of the regression model, evaluating the developed subsystem based on the metrics of accuracy, precision, and F-score. As a result of testing the above-mentioned metrics of the developed subsystem, the following conclusions were obtained. Normal and subjective cognitive impairments are poorly represented in the provided data. The group of patients of the normal class is also represented by a small set of described characteristics, which significantly reduces the set of observations suitable for the work of the regression model. A group of patients with mild cognitive impairments is diagnosed with an accuracy of 83%. The results are not relating to the overfitting of the regression model due to the additional cross-validation of regression model output. The testing also revealed significant characteristics, information about which was used by medical professionals to detect cognitive impairment at an early stage. As a result of the work, the set goal was fully achieved. All the tasks have been solved and the further development of the work is planned. In the future, it is planned to implement the ability of the subsystem to adapt to work with a wide range of tabular numerical data in a CSV format. It is also planned to implement the possibility of diagnosing other neurological diseases based on the data obtained from medical examinations.